Hello, everyone, and welcome to the July Webinar Wednesday. We'll be starting in just a couple of minutes. Before we begin, we'd like to take a moment to say a heartfelt thank you to all of our 2026 PHUSE supporters. Your continued support plays a vital role in making everything we do possible. All right, we're going to go ahead and get started. My name is Michael Rimler. I am the Open Source Technologies Director at PHUSE, and this is the July Webinar Wednesday. I'm going to be the host today, and we have a nice packed agenda planned for today. I'll start by sharing a few updates from PHUSE, including upcoming events and opportunities, and then I'll hand over to our presenters who will share their award-winning presentations from the most recent EU, APAC, and US Connects. Then we will wrap up with a brief Q&A, which is your chance to ask the presenters or me any questions that you may have from our talks. And you can submit any questions that you have through the Q&A feature, but please do specify who the question is for so we know who to direct it to. So some updates from a PHUSE perspective. We have 4 single-day events that are calling for speakers. If you're interested in presenting, please submit a 150-word abstract to the event's chairs by the deadlines on the screen now, and you can find the events chairs by navigating to PHUSE.global and looking for the single-day events section. There are also 2 single-day events open for registration. By attending, you can learn more about impactful topics and connect with other healthcare data scientists in a city near you. Find out more about the event's agendas and register through the PHUSE website. As well, presentation and registration openings. There are also sponsorship opportunities available at single-day events across the next few months, and you can find more in the prospectus on the PHUSE website or by contacting events@phuse.global. There are 2 multi-day working group events open for registration. These are great opportunities to learn from experts in their fields about some of the most pressing issues within healthcare data science. You can secure your place at both of these events via the PHUSE website. The working groups have also recently shared their Q2 report, which is a summary of the activities over the last 3 months. And the Risk-Based Quality Management Working Group has also shared a white paper on RBQM in first-in-human and/or small clinical trials. Both the white paper and the Q2 report can be found also via the PHUSE website. The EU Connect's overview agenda is now live. You can take a look at the sessions on offer from the welcome event to the closing remarks. There's still time to secure your stay at the Connect Hotel at a discounted rate, which you can do through the PHUSE website as you register. Companies can also get involved at the EU Connect by supporting PHUSE and sponsoring the event. There are just a few packages left, from sponsoring the PHUSE app to being an exhibitor for the duration of the Connect. If you're interested, you can find out more through the Connect prospectus on the PHUSE website or by contacting events@phuse.global for more information. Early bird registration is now open for the APAC Connect 2027, so secure your place by the 25th of September to enjoy a discounted rate. You can also book your stay at the Connect Hotel using the links available on the PHUSE website. The agenda will soon be released on the theme From Prototype to Practice, how APAC is driving trust, impact, and transformation, following 619 abstract submissions. Plus, don't miss your opportunity to showcase your company at the event. You can find out more about the benefits of sponsoring the APAC Connect in the return on investment summary documents, or find out more about the available packages in the Connect prospectus, both of which are on the PHUSE website. And please reach out to the PHUSE events team via events@phuse.global for more information. Early bird registration for the US Connect is now open. Book before the 23rd of October to join us in Dallas, Texas for a discounted ticket price. As with other Connects, there are still sponsorship opportunities available, but hurry as the packages are selling fast. Most excitingly, though, the call for papers is open until the 4th of September. You can submit your 150-word abstract before the deadline for your chance to present at the US Connect and share your ideas with an audience of passionate healthcare data scientists, regulatory leaders, and others in our field. There's a brand new stream that you can submit your paper to as well as the 2 PHUSE pavilions. By presenting at the US Connect, you can build your career and open yourself up to new opportunities, such as potentially receiving awards from the PHUSE recognition, like today's presenters. The PHUSE recognition framework celebrates people who have given their time and expertise to FUSE, especially those whose contributions have driven clinical data science forward. When you receive a FUSE award at a Connect event, whether that's Best in Stream, Best Connect Newcomer, or Best in Connect, you'll receive a certificate at the closing ceremony and be promoted on the FUSE website and social media channels, putting you front and center of our community. I highly encourage you to submit an abstract for your chance to present, both at the US Connect and on global platforms like today's webinar. And with that, I will hand over to our first award winner, Soren, for his presentation.
Yes, thank you very much for the introductions. I will show off what I showed off at the EU Connect back in November. And I've tried to keep it as close to that as possible, because the whole point of this presentation is that it's kind of universal ideas. I'm showing off my very specific example of how we're doing it, but it's more the philosophy of how we are doing these things. The only change I've had is that I've changed my title, because my title has changed, which is good, because before it was Launch Data Scientist, which with the image here sound a bit threatening. And also now that it actually includes HTA, which is what I do, it gives me a nice lead-in to explain what HTA is. It stands for Health Technology Assessment, and it covers what happens after you've done the submission. So when you do a submission, you usually have a few regulatory authorities like EMA and FDA, and you have to prepare a package, you deliver it, and then you're mostly happy and you're done. The thing is that after you've done that, you have to negotiate with each of the countries whether or not they should actually publicly reimburse your drug. And that means that each country has their very own way of doing things, and each of these countries has their own timings. And it means that everything is basically as having a Q&A with the entire world at the same time. That's why I usually put it. So I think all of you know that when you work with governmental agencies, their requests come with very little warning, and there's not really any room for negotiations. You just have to sit in a room where they drop the bomb, everything is on fire, and say, this is fine, because you just have to adapt to it. So we usually liken it to having a completely blue sky and then having a bomb dropped on you. And it means that if you're not prepared, then everything will be on fire. So the traditional problems when you have something like this, and especially in a field like HTA, where you are working together with market access, you're working with local affiliates, there will be a lot of these email chains where people are asking each other how to do different things. You might have to talk to a trial squad. You might have to talk to multiple trial squads, because often it's a lot of different trials at the same time. Because everyone is sort of new to this every time, there will often be some quite unclear request formats. You will have to manually translate the business language into something which is actually useful when you're programming things. And all of this can very easily give very scattered, unfindable documentation, because everything lives in someone's inbox. So the problem here is that you have to maintain your data flow across multiple departments. And each of these departments tend to have their very own way of doing things, especially if you're in a big company. So if you don't have some very good systems, it ends up being extremely time-consuming. You end up having a project derailing bottleneck, usually someone who doesn't answer their email. And in general, it's just a coordination nightmare for everyone involved. So what you need in something like this is something that's structured, something that's scalable, and something that works in practice. You don't want some fancy thing that someone is selling you that could potentially solve everything. It needs to be simple, and it needs to be something you can do right now. So I'll show off the components that we have used in our system. And the first one is very simple. It's an Excel request form. It's a single standardized entry point where every single request has to come through here. Then it's an AI-powered specification translation tool, which converts the business language into technical specs. Then it's simple Kanban board management, because it gives transparency and it enables autonomous work from the people you have programming for you. Then we have built modular startup programs, which is reusable testable templates for the most common request types. And finally, an automated documentation system. So you have an audit trail without having to do too much manual effort. So first, I'll go through this single Excel request form. It is just a standardized submission point. The idea here is to eliminate confusion on where things should go and where you keep things. The good thing about Excel is that everyone knows how to use it. It doesn't matter which department they're in, and it's easy to share with everyone you want to share it with. It looks like this. It is very, very simple. The first thing is you need to know who needs this. In our case, it's usually a country. Then you need the initials of the contact because we have our internal Novo Nordisk initials. Then you need which study the analysis is requested for. And this is especially important when you're working in HTA because quite often you will have to combine multiple studies. Because they just say, I want descriptive tables. They don't know which one of our studies they need it for. So they need to put this in as well. Then you need to put in the priority. And when I first designed this, I was thinking, well, doesn't everyone just want to put themselves as high priority? But it turns out that if you make these request form public, then you're shaming people into putting themselves at a proper priority. Because if you see that there is a nice request, which is put at high, and you come in as an exploratory group, and I would just like to know how this thing works, then it's really hard to put yourself as high next to this request. So it actually turns out that people are very good at putting the right priority for their request. Then they need to put in what kind of analysis they want. So what type of analysis they actually need, when they need it, and very, very importantly, is their flexibility. Because it turns out that, again, with this kind of public shaming, people often are actually relatively flexible about timelines. And then finally, you always need to put in a comment field where you can put in additional context because people feel heard when they can put in their comments. And then you can decide if you actually want to read them or not. Okay, so the idea here is that you have a very clear process. You have this form that you fill out, and then you have an email which is sent to a single contact. And in this case, that's me because I'm the portfolio manager of these requests. The next part is this AI-powered specification translation, which is just an LLM-based program which translates plain text into the technical specs that we use in our programs. And it's a Shiny app that looks like this, and I know this is very small, so I'll just zoom in. So this is an actual request that we received, including you can see that they forgot to put in a space after week. And this is quite common what we get. Then you submit a request, it runs through it, and then it puts out something like this. And again, I'll just zoom in. You see here, there's an example of where it pulls out the param code and the param, where you can see it looks for this HFpEF subgroup with high BMI, and it shows you what part of the request it used to identify this and what type of request it is. Because the idea is you always have a human in the loop. You can never trust them just to do things autonomously. Good. So the idea here is that this specification tool bridges the gap between the language of the requester, who is usually market access people, so they're not technical, they're technical people, but not programmer technical people. And then it translates it into the system requirements of our programs. All of this goes into our Kanban boards, which has multiple different columns. The first one is the backlog. The idea here is that you put in anything that is ready to be picked up by anyone. So you don't need to have someone say, oh, you do this, you do this. Anyone who feels like they can do these backlog tasks can just pick it up and put it into implementing, where it is when it's currently being worked on. Then when it's ready for review, you put it into on review. So you can see, okay, now someone should review it, because often it's different people who have the capabilities of doing the coding and doing the review. Then probably the most important part we have is blocked, because here you put in tasks which are waiting for either data or clarification. And if there's clarification need, then you should always tag the person who can unblock you, because otherwise you'll end up having that people are waiting until the next meeting to move on. And sometimes you only have a week to deliver something. So you don't have time to wait for people to just realize that you should actually help someone. So you need to tag people. That's very important. Finally, closed, finish, deliver, everyone's happy. Each of these features is always colored by priority, so you at a glance can tell which task you should be taking. And then, of course, each of these features can be subdivided into user stories where you have actually what should be performed. It looks like this. There's actually one more which is analyzing, but that just means that we're not finished scoping things. And you can see here at a glance, you can tell that the yellow one is higher priority than the green one, which is why even though the green one has finished 5 out of 12 of its user stories, it's actually not what's being worked on right now, because we have to prioritize the yellow one. So really quickly, you can see what you should actually be working on and who's responsible for each part. Good. So another thing about these boards is that all the information on these boards is extracted for resource planning overview of the progress, which I cut in the interest of time in this presentation. But if you go to the PHUSE website, you can see the accompanying paper where I'm showing this off. And even if you're not interested in this, I would be very happy if you saw it, because this app is probably the thing I'm most proud of ever making in my life. So it's very sad that I cannot show it off. Then we move to modular standard programs, where the idea is that we have reusable templates that handle most of the most common requests. So it's things like baseline tables, ANCOVA, COTS regressions, logistic regressions, things like this. And the idea is that we focus on configuration rather than coding. So we update the parameters which goes into these programs. We do not touch the code. The code is static and it's built to be flexible in this regard. So it means that it's tested and reliable because we used it literally hundreds of times and we know it's working, so there's no reason to touch the code. So the setup of this is here. We have a program here doing linear regression analysis. So you will feed it data from your trial, which is usually multiple imputation data and subject level ADSL data. Then you will have some functions, which is, in this case, some linear regression functions and some general utility function, how to load data and things like that. Then you have your input files, which has your specification of what you want to be doing, what subpopulations you have, things like that. And a metadata dictionary, which translates the param codes into the actual parameters that you want to be showing off in your output program, where you send all of the analysis data that you've done, because it's a very good idea to have your modular programs produce what is basically X data sets, which is then loaded into your outputs, because in that case, you can change your outputs up without having to constantly change your X data sets, because that's the expensive part of doing this. And then finally, you export all of it as your formatted tables that you want. The important thing here is that the only thing that ever changes when you're running something is these input files. You just run the specification file, you just run the param. And the AI tool I showed you before, that produces this specification. So you can actually, in theory, receive a request, send it into the tool, it produces the specification tool, you run your modular programs, you have your outputs. So in theory, everything can be done in one shot. Usually we check through things because you need to do review. But in theory, everything could be done in one shot. So this means there's way less overhead because you know what programs to use. It means there's less review needed because you just do output review and a specification review. And the workload that we have then switches to more complex one-off analysis because not everything can fit into these modular programs. It's only the most common things, but it also covers maybe 80 or 90% of the outputs that we do is these more standard things. That moves us to the automated documentation system. The idea here is that we are regularly scraping all of the Kanban board history, which produces the documentation, and it's linked to the actual activity that was done. Because whenever you move your features on the Kanban board, you need to write what was happening and why was it moved. So this way, you always have the task history linked to the original requests. The features look like this. I don't want you to read all of this, but basically, you can see there's a lot of information here. This is great, and then gives us a nice markdown document which looks like this, where it includes links to the original feature. It includes links to the work items, and you can see the status of all of these things. It has the description, it has all of the discussion, and it has each of the work items is also linked in here with their discussion. This does not eliminate manual inputs. Like I said, everything that's scraped here is written by humans, except for the history of when things were done. What it does say is having to write things twice. And it means that you have a single truth, which is the Kanban boards. Also, importantly, it provides a searchable, machine-readable format, so there's no docx's, so you can read this and search in it very easily. And this has become more important now than when I made this documentation, this presentation originally, is that it means you can also feed it to your LLMs because it's markdown, so it's super easy for them to read as context. So maybe when you're looking at what I presented here, you might think this seems very, very simple. Does this actually make any difference in real life? Isn't this just common sense? At least that's what I was thinking when I was writing the abstract. So I decided to do some digging. So I went through my mailbox because that's where all the standard requests came through. And we had a time before we implemented the system, and then we had some time after we implemented the system. And I tried to figure out how much impact did this actually have on people being confused about what is being delivered, have to redo things twice, things like that. And to my surprise, it actually made a huge difference across things. Take these numbers with a grain of salt. I don't think we reduced confusion with 100%. But it does show that when you look at this, there is a clear reduction in basically any keywords I could think of when I was looking for this. You can look in the paper if you want to see exactly how I did it. But I think the important thing is that if you try to translate this rather arbitrarily into time, it looks like this. We have reduced our person hours per thread, and thread is basically a delivery in this case, from roughly 5 hours to 2.5 hours of admin. And let's be honest, this admin is wasted time if you actually spend time on it. So it's a huge difference in doing what is relatively easy to do. So the key improvements we had: reduced response and admin time, the response time because of the modular things and having to get things to move quicker. We have improved our quality because we standardized our way of doing things. We eliminated the documentation gaps because everything lives on the Kanban boards and the Excel sheet. And everything is in a very scalable, transparent process. Everyone can see what's going on at all times. Our key insight in doing all of this, and what I hope you take from this, is that thoughtful integration of these relatively simple tools is much more important than revolutionary technology. And now I maybe can hear you mumble, well, you did talk about AI, but I would actually say that is the least important part of all of this. The most important thing is actually to keep a very structured track of what you're doing. That is much more important than anything else you can think of. And you can do whatever systems you want, but this is the system thinking that I hope that you take with it after this. And I also hope that if you do this and implement it, then you can actually be ready for the next bump from the blue and be thinking, even though there is natural catastrophes happening outside, you can feel relatively safe and think this is actually fine. Thank you very much for your attention, and I'll hand it over to William now.
All right. Well, thank you, Sharon. Right. Okay. So, hi everyone. Good morning, good afternoon, good evening from wherever you're joining from. My name is William Kwan. I'm a senior industry consultant at Health and Life Science team at SAS. And today, with my colleague Ashwini, we would like to share with you the key consideration and strategy in building a trustworthy real-world data analytic platform, which we presented in a PHUSE APAC Connect this year in India. Okay, a quick disclaimer. So for a long time, the industry used RCT as the gold standard for establishing efficacy and safety of medical products. Well, while that remains true, the industry is hitting a wall of increasing R&D costs and demanding faster speed to market. So RWD and RWE is one of the solutions to help the industry to minimize the risk where you can't find enough patients in a rare disease clinical trial, or serve as the external control arm where ethical reason make a placebo arm is impossible in a clinical trial, or even help demonstrate the cost effectiveness of the new product. And as you can see from the recent news, that regulators aren't just considering real-world evidence anymore. They are actually leaning into it. So since 2018, the FDA has been dropping multiple guidance documents, covering the use of EHR, medical claim, and registry. And in Europe, one of the famous real evidence network, the Darwin EU network, is already connecting regulator to data from over 180 million patients from over 30 data partners. And this is continue moving forward to provide a robust framework for real-world evidence generation in EU. And in Japan, well, the PMDA, they're actually increasingly using real-world data for orphan drug and pediatric therapeutic area as the external control arm. And you can see they also released the guideline on some example and some consideration of using real-world evidence as an external control. So we can see that the regulator is increasingly adopting real evidence in a review process, but we believe that they will only accept it if the evidence is regulatory grade and trustworthy. So how do we build that trust? Well, we think it comes down to three things. The first is data and method and process. So it is crucial to prove to the regulatory authority that the data and the method being used are reliable and relevant to the regulatory question, and also to showcase the whole evidence generation process is reproducible and transparent. And we believe that with a trusted and modern real-world data analytic platform, it can help the subject matter experts getting insights from real-world data faster, reduce risk of being non-compliant, and maximize the ROI of your organization's real-world data investment. So let's jump into it. So first, we talk about the data. So we're no longer just dealing with the CSV file from your hospital claim data provider. We're talking about diverse data sources. So a modern analytic platform must be able to ingest all of this, such as the JSON file, Parquet, image data, unstructured data, and streaming data, etc. And it can do it across any cloud environment and data lake provider. So the user can consume multiple types of data from a wide variety of environment and sources to leverage more diverse real-world data in large volume to gain deeper insights to understand the population in the real world. And it is not enough to just have the data. You must also prove it if it is fit for purpose. Is it relevant and is it reliable? We need to know if the data source covers the right study population and if the outcome we care about are actually captured in the data source. So a modern platform shouldn't make you wait weeks or days for that result. It should offer rapid data profiling, like visualization and automatic analytics that let you spot quality issue before you start the real world. And it should offer the tool that you can check for completeness, accuracy of your data, so that you can understand the data element, data quality issue, and gain insight quickly. And reliability also means provenance and traceability of the whole process. So we need a systematic way to document how data is transferred and transformed. So once the data quality issue and the ETL process are identified, a modern platform should provide user a systematic approach to control data quality, to secure data provenance, and automate those repetitive tasks for data preparation, so that we can increase confidence in the final output of data curation and data transformation. And too often, a real evidence study is just treated like an one-off project. And I think that is a massive waste of time on the intellectual property. So in my view, the custom coding for every study from scratch has to stop. So we need to actively manage our analytical intellectual property. So that means creating a library of validated, reusable analytic template, including those standardized patient phenotype or the definition for the covariate of your interest that all pass the quality control and validated by the expert within your organization. And this isn't just about speed. It is about having the confidence that the code you're using is reliable. So the modern platform help you efficiently manage analytical asset generated from the past project, and so that you can leverage validated analytic asset to produce reliable results, and also establish the best practice for study with different complexity. Because some study might be simple, standardized, but some study, have the more complex you need require some custom code. And trust is also built on transparency. So, and the regulator, they also require reproducibility in your real-world evidence generation process. So if a regulator asks you, how did you get this result? You shouldn't have to spend weeks digging through those execution logs or try to find in the program or data set. A trusted platform needs to maintain a complete lineage from the raw data to final result and its execution log. So it helps the user to be able to point to a specific number and show exactly how it was derived and where it was used. So with the help from a trusted platform, the user can ensure a clear governance on data and analysis to increase transparency, reproducibility, and traceability of the analysis process. And yes, we can't talk about analytics today without talking about AI. The industry is exploring how and where AI can bring the most value to organization in the enterprise level. So we can use AI to identify treatment patterns, stratifying patient subgroup, pulling insights from all of the massive clinical notes. But in pharma, we cannot use a black box AI. Black box model are useless in a regulatory setting. So we must integrate trustworthy AI best practice into the platform. So a modern platform should be able to support you to utilize end-to-end trustworthy AI capability, to explain why a model made a specific prediction, and be able to monitor the model to make sure the model don't get biased or stall over time because the data drift, so that you can develop, validate, and deploy AI model for real-world data analysis in a consistent, ethical, and a reliable way. So what I mentioned earlier is more focusing on a business team's perspective. So in this slide, I would like to walk through a few additional consideration, but it is more for, from the IT team perspective that can really help streamline the real world evidence generation process. So when we talk about handling real world data, we are often dealing with very large, complex data sets. So having a cloud native platform becomes really important because it gives you access to scalable computing power and storage, which means you're not limited by local infrastructure. And based on your analytic workload, you can scale up when the workload increase and scale down when you don't need it. And high performance analytic power can really help your team process large volume of data much faster. As we all know, in real world evidence study, we need to, usually need to go back and forth to test the hypothesis, to check the feasibility, etc. So this is really critical when timelines are tight. Okay. And just as importantly, if the platform can be hosted in a secure GXP qualified environment, it can reduce the burden on IT teams. And at the same time, researcher, the user across different geographic location can securely access the system with strict access control in place. And now building on that, let's talk about the collaboration. So a real-world evidence generation is rarely a one-person effort. It's not even a one-team effort. You typically have people from different functions like data science teams, epidemiologists, medical affairs, commercial, etc. And they all working together. So having a platform that supports collaboration across this role is key. For example, a medical affairs person might prefer using the interactive data visualization tool to explore patient cohort, while a data scientist might be working in the pure coding environment to run more complex analysis. So a good platform allows both to coexist and work together seamlessly. And with shared access and even and with those low code, no code interface, more people in the organization can participate in data-driven decision making. And ultimately, this helps break down, data silo, analytics silo between teams, which improves both productivity and insight sharing. And another point is the analytic capability. So we're talking about both classical statistic and advanced analytic. So on one hand, you still need a classical statistical method. Those are essential for clinical trial analysis or health or HEOR study, especially when you're preparing for regulatory submission. But at the same time, there's increasing demand for advanced analytics, things like AI, machine learning, computer vision, natural language processing, LLM. So these are especially useful for exploratory analysis. And looking ahead, if advanced analytics are going to be used for submission, then governance becomes really critical. The platform need to support transparency around how models are being trained, how they're used for prediction, how they're monitored over time. And then another important point is the openness. So an ideal platform should support multiple programming language like SAS, R, Python, and others. So that flexibility allows users to work in the language they are most comfortable with, which can be significantly important to improve efficiency. It also has implication for talent, right? Like if your pattern supports a wide range of tool, language, it becomes easier to attend and attract a skilled professional. And openness also means integration. So the platform should be able to connect with third-party application system. And with the REST API, you can enable seamless data flow from the data management system all the way to the external application like dashboard or mobile app. And also with the increasing use of large language model and Gen AI technology, it is critical that the platform could also leverage the Model Context Protocol, MCP, to create a link between the analytic workflow and an AI-powered application. So with that kind of openness and integration, it really can help your team to work with data and the latest technology seamlessly. And finally, a single end-to-end platform, because in many organizations, people are still switching between multiple tools for different purpose, for different steps, like data preparation, analysis, reporting, and that can be inefficient, introduce risk and increasing burden on IT's responsibility for governing tool and data security control. So a single end-to-end analytic platform brings all these steps together, from data ingestion to analysis, large language model use, automatic workflow, everything happens in one place. So this not only saves time, but also improves governance and collaboration. So just to quickly sum up, when we talk about a trusted real data analytic platform, we really need to make sure that how the platform can support the data analysis and process to be, reliable, reliant, relevant, and also trustworthy during the whole process. Okay, and thank you. That is all from my side. And then I'll pass it to Frank. Thank you.
All right. Thank you, everyone. I'm Frank Menius, and I am an AI skeptic. And so I'm going to give you a guide for using AI from my perspective. A little bit about me. I am a senior trainer at Atorus, but I've been in the clinical research industry for about almost 10 years now. So that's what I bring. For a little disclaimer, though, the opinions that I share in this presentation are mine. They're not PHUSE's. They're not Atorus's. So I said all of that to say this. Again, I'm an AI skeptic. I look around and I see what's happening with AI, forced insertion into pretty much every aspect of our lives, and it really doesn't make me happy. I do think that we're, approaching a point where it's causing, at least right now, a little bit more harm than good. Do I think we're approaching a singularity like the Terminator? No, I don't. But I still have some issues with AI. First, environmental impacts. AI is sucking down massive amounts of our clean water supplies, using in some places 40% of our electricity. I know that's the stated amount that's being used in Ireland, for example. And it's consuming massive amounts of other finite materials and resources. AI is accelerating the crisis that is global climate change even faster than it was before. On top of that, it's fueling a pretty terrifying trend in global misinformation, propaganda, and harassment. AI in its current state is a threat to democracy worldwide. Finally, AI is increasing your electric and water bills. And if you shopped for a computer lately, you've seen a dramatic increase in the cost of RAM, GPUs, and solid state drives. And there's evidence that we may be in somewhat of an investment bubble, similar to the dot-com bubble of the 90s, with 95% of companies who invested in AI seeing zero returns so far. But you guys are clinical researchers. You didn't come here for all of that. You came here to talk about programming. There's a lot of anecdotal evidence out there that says developers are slower, understand their code less, and even forget how to do code when they're using AI. The anecdotal evidence comes in a form of statements, Reddit blogs, surveys, etc. But as of the time of my writing of this paper, there was at least one randomized study to support that anecdotal evidence, and that is the meter study from July of 2025. Now, all of that said, I'm pretty sure that we're stuck with it. We're stuck with AI. I'm also pretty sure that for better or worse, your management is probably forcing you to use it in some form or another. So my goal here is to show you how you can use AI for programming safely, effectively, and then you can make your own decisions. Now, I have a 3-hour course on this topic that goes into types of AI, its limitations, some hands-on practice using it, but we don't have time for all of that here. So we're going to get quick and dirty with some tips and quick tricks and recommendations that you can take home and use today. So the first thing I want to look at is safety. How can you safely use AI to do that? I need to kind of talk about briefly how AI works. AI models gather information from the internet and their training data, and they use that information to recognize patterns and provide a predicted response based on your prompt and those patterns. It doesn't think, it's not creative, it recognizes patterns. It is not intelligence. Okay, let's be clear of that. It is not intelligence, not yet. So when we're talking about code, it's going to be looking up open source code across the internet, any code that you provided as reference, and any internal training code that it may have. So there are some things to remember. First, because AI is using all of this open source code, its sources may be outdated. They may be injecting insecure libraries or security vulnerabilities into your code. AI training data may not have access to the most up-to-date security patches and information. So you need to keep that in mind. Second, as more and more companies introduce large language models and AI to their organizations, many have given their AI access to their data. And this can lead to the unintentional leak of sensitive data. Perhaps API keys, credential codes, proprietary algorithms, or even patient data. And this is especially true if the AI returns to the organization's data to the AI provider servers for processing. Also, AI does not forget. The rule of thumb once on the internet was that once it's there, it's always there. And that's kind of the same with the AI. It doesn't forget this stuff. It's taking it away and storing it unless you have it firewalled on your own system. So this brings me to my number one tip and that is do not put your proprietary code or data into a non-secure AI chatbot. Okay. With that said, let's talk about things that we can use AI for in programming. That is, it is particularly well suited for. AI can be helpful as a learning tool. Maybe you're learning a new language. Maybe you're a SAS programmer and you want to learn how to perform some SAS functions in R. You can give it some SAS code and it will reasonably give you back some R code. You can even ask it to provide R code to do certain tasks. So here's some very basic SAS code that I wanted to duplicate in R. And here's the prompt I use. Translate the following SAS code into R. Here's the resulting R script and some notes that it provided on programming in R. And here is the results from running the R script below the SAS app output. Excuse me. And so this really isn't too bad, but it could be a little better. Interacting with AI is a conversation. It requires feedback. So I'm going to ask the AI to make a group header uppercase because it's uppercase in the SAS output, and I want it to be uppercase in the R output. So this is my prompt and the resulting code and the output. The prompt I used, though, didn't give me what I wanted. And that's, it's exactly the same as it was before. And maybe you already knew it wouldn't work. So I have to kind of refine my feedback a little bit. The AI is great with syntax, but they're a bit lacking when it comes to context. They have no common sense. So I made the assumption that when I told it to capitalize the group column, that it would change the header. But no, it went and tried to capitalize the values in the group column. Well, they're already capitalized. And so I have to make my prompt more specific to get the group column to be uppercase. And once I do that, I can actually get the results that I want. So you have to have that conversation, and you have to make sure that you're not letting the AI make assumptions. So tip number 2 is it's all about the prompt. The prompt needs to be specific, it needs to be detailed, and if you can read it and you must make any kind of assumptions, the AI is going to make it to assume wrong. You can put bets on that. And if you need to provide feedback to iterate and fine-tune, go ahead and do so. And then if you're feeding the AI code, you want to chunk it into smaller sections. AI is notoriously bad at working on large, complicated pieces of code. So if you want to replicate something, break it down into its components, and then try and replicate that. Something else that we can easily use AI for is commenting our code and making our code a little bit more readable. So we have AI as a learning tool, and now we have commenting and readability. Programmers notoriously do not comment and document their code very well. And this is one place where AI can make a significant improvement in the programmer's output and really their life. Similar to how we ask ChatGPT to transfer SAS code into R code, we can also have it evaluate existing R code and make suggestions for commenting. So I took some code from our open source library of creating ADSL datasets in R, and then I removed all of the comments. And I asked the AI to add comments to the following code. And so here are some of the results. It added comments describing the libraries and reading in the data. It even appears to know a little bit about CDIS data and its variables. And overall, I'm pretty satisfied with these results. And this may actually be better commenting than some of the programmers that I know and work with. But with everything AI creates, you still need to read through it with a critical and trained eye. You cannot just make it do this and then present it as finished product, because you cannot trust that it got it right. You have to review it, and you have to be able to identify the mistakes. One comment that I heard about AI the other day was that how do we, if we're all putting our information into AI and we're just accepting its values, how are the new programmers going to know when something's wrong? And so that's something to consider. How are you going to recognize when it's wrong if you're just trusting the AI? So my third tip is one thing that helps is this, and it is to develop or use a consistent programming style guide for your team or your company. The more consistent your code is, the more the AI is going to be able to provide you with the appropriate code examples that match your needs. And you can even reference existing style guides with their name or URL inside of your AI prompt to ensure that the AI is taking the programming style into account. So that brings me to another thing that AI can be used for, and that is debugging and testing. Okay? Like I said before, AI is a master of syntax. AI can greatly have success at identifying the source of hard-to-find errors. It can scrape the internet to find detailed explanations of errors, and it can be very useful in writing unit tests for expected results. But in order to use AI to debug, you must follow some key principles first. So first, context is key. The more context the AI tool is provided with, including libraries, frameworks, specific challenges that you're facing, the better the response that you're going to get from that AI. As with everything else I've said about AI, specificity matters. More specific, provide context. And then you need to know the AI's limitations. Review and understand what the AI suggests. Do not blindly accept the AI output. Always verify the suggested fixes and solutions. And remember that AI might hallucinate and tell you that there are 4 N's in mayonnaise. So this is an older one that popped up sometimes, but you can see the AI can't tell you how many N's are in mayonnaise. You also want to combine your use of AI with traditional debugging methods. Use AI as a starting point, but perform the debugging yourself thoroughly. And then if the initial AI suggestions don't help to solve the problem, continue the conversation, iterate and refine the prompt, and provide feedback to the AI until you get the desired result. By combining the strength of AI's knowledge of syntax and pattern recognition with your own knowledge of debugging workflows, you can significantly reduce the time that you spend debugging. But at this point, you cannot just turn over the debugging to the AI, especially if you have complex code where the debugging might introduce additional problems or bugs into your code. So that brings me to my final tip that I have time for today, and that is validate. You're going to have to validate and verify AI's output. The AI is only as good of a coder as you are. If you can't follow and understand the code that it's generating, then it's probably wrong, or it is leaving out some important edge case in your data. Use AI as a tool, but not a replacement. I suggest going through the code line by line. Look for holes or inconsistencies where the AI might be struggling. What assumptions did the AI make? Is the code efficient, especially with larger data sets? What are some of the edge cases that the AI may have overlooked? So, for better or worse, AI is here to stay. Whether you're an AI skeptic like me or an enthusiastic endorser of the new technology, there are some key things to keep in mind to use AI to the best of our ability. Just like a chainsaw or a hammer, AI is a tool, and you must know how to use a tool correctly to avoid causing damage. You want to keep my tips in mind. Again, here they are. And with that, I want to thank you, and I'm going to turn it back over to Mike.
Thank you, Frank, and all of our presenters today. Great topics. We have a couple of minutes for Q&A, but I haven't seen anything come into the question and answer. So given the timing that we have, I'm going to make an executive decision to skip through the Q&A. Again, thank our panelists for their presentations, and also thank you all for being here and attending this month's Webinar Wednesday. A reminder about all the events that we gave a brief overview of in the beginning. Please take a look, consider registering, submitting abstracts, and getting involved in any way that you feel appropriate. So thanks everybody for joining, and have a great rest of your day.